Hi, in this session we will discuss about voltage multiplier. We have studied the circuit in the theory classes. Still, I would like to introduce it in a simple manner. That is, if you give an AC signal here and then its peak value of the voltage Vp, as you know, will be √2 times the RMS value. One thing you should understand is when you use a multimeter or a voltmeter to measure an AC signal, we are actually measuring the RMS value. The peak value of that AC signal would be √2 times the RMS value. For example, if my VRMS is equal to 7 volts, then Vp would be √2 times 7. That is 1.414 into 7. So that will be my peak value of voltage. So this is a circuit where when you apply an AC signal, you can upgrade the voltage across this to Vp value, and across these two capacitors, between these 2 points, the voltage would be 2 Vp, and across these 2 points, the output voltage that will develop would be 3 Vp. And if you go on extending the circuit as the dotted line shows, then across these points it would be 4 Vp and so on. So this is the concept of voltage multiplier. Though the circuit will appear to be a bit complicated, I'll help you to draw it in a very simple manner. Suppose this is our AC signal. I will draw positive, negative of the capacitor, then positive, negative of diode D1, then positive, negative of capacitor C2, this is C1. Then in this pattern, I would like to continue the circuit. Positive, negative of diode D2, positive, negative of capacitor C3, positive, negative of diode D3, then positive, and if you want to proceed further, you can have the D4 diode, that is positive, negative. So this is the framework of my voltage multiplier circuit, and I would like to complete the circuit with simple direct connections. So here I have left out the capacitor C4. So once again I'll follow the path for you. Signal generator or the signal, C1 capacitor positive, negative, diode positive, negative, capacitor positive, negative, diode positive, negative, capacitor positive, negative, diode positive, negative, capacitor positive, negative, diode positive, negative. So the circuit You just need to complete it with direct connections to look like this. So this would be your simple voltage multiplier. Let's see where we will get the voltage outputs. Across this capacitor, you will get Vp. Across these two capacitors, you will get 2 Vp. Across these two capacitors, you will get 3 Vp. And across the fourth capacitor and the first point, you will get 4 Vp. So this is the circuit which we have drawn neatly. So hope the circuit is no more a complicated one. Capacitor positive negative, diode positive negative, capacitor positive negative, diode positive negative, capacitor positive negative, diode positive negative, capacitor positive negative, diode positive negative. Just complete the circuits. I have put this part of the circuit with dotted lines because we are not going to measure it or construct it as far as this experiment is now concerned. We will just measure how the voltage Vp, which appears across this, gets multiplied and appear as 2 Vp here, appear as 3 Vp here, and that is all. Now let us construct the circuit in the breadboard. So this is a capacitor. I have taken 100 microfarad capacitor. Here you can see it, 100 microfarad. The longer leg is a positive leg and the shorter one is a negative leg. I would like to bend the capacitor legs, the longer leg in this manner for convenience. So this is a positive and this is a negative. Now the diode I would like to introduce, though you would be knowing it. This is a diode. This diode has a ring, silver ring at the negative end. You can see the silver ring at the negative end. I mean this end. This end is a silver ring, so that's a negative. This is a positive end. So we will use 3 capacitor and 3 diode to do this voltage doubler and tripler. We are not going for the quadrupling. So the first component, as you can see, is this capacitor C1. So positive, negative. I'm making use of this here. Positive, negative. Now I would like to take this diode. Positive from here and negative goes here. Next capacitor, positive, negative. So positive, negative. Next diode, positive, negative. Hope it is clear. Next diode, next capacitor, that is this capacitor. I finished this 4 components. Now this capacitor from the end, negative end of this diode. I'm trying my best to construct the circuit exactly like the picture that we have drawn. So positive, negative of the capacitor. Now next diode, positive, negative. So just as we drew the circuit, we have done it like this. Now we need an interconnection between these points, and the signal should go here. So I will take two jumper wires and try to connect this point with this point and this point with this point. That is, I've done this part and this part using two symbol wires. So now what I have to do is give the signals over here. I don't have a conventional signal generator with me. I'm using a transformer coil to step down to 30 volt from here to 6 volt here. This is a center tap, but I would like to take just a output from this point and this point, which would be 6 volt. So these are the two connection ends that I will be taking. This is one wire and this is the second wire. So these two ends, this blue end and gray end, those are going to be my input signal terminals. Now these are the two wires that I have taken for the AC input. So one I will connect it. My signal should be connected here at this point. So one of the end, I will connect it at this point. As it is an AC, you don't have to bother much about the polarity. One connection there and one connection here. So I have given the input and switching on the input, power supply to the transformer. Instead of this transformer, you can have a direct DC supply from your signal generator. Just because I'm not having it with me, I'm opting this transformer. Now we'll measure what is the situation of voltages at various points. First, you should understand that the input voltage would be Vp across this capacitor, and it will be 2 Vp across these points, and it would be 3 Vp across these points. So let us see what is Vp now. Let's do the measurement. So first we'll see what is the Vp value across this capacitor, C1 capacitor. So this is a C1 capacitor. We'll measure the output. So across this capacitor, let me measure the voltage. So hope you can see it is 7.7 or 7.8 or 7.6, I'll take it as. So Vp is 7.6. Now I should measure the voltage across this capacitor. That will be 2 Vp. That is 15.3. Please note down. Okay, 15.1. Please take a pen and paper and note down the voltage so that we can do the calculation here itself. So Vp was 7.6. 2 Vp measured across this capacitor is 15.3. 15.3, and 3 Vp should be measured across these two capacitors, that is this point and this point. So it is 23.8 22.5. 22.5. So hope the measurement is clear. I measured the VP across this capacitor, 2 VP across this capacitor, and 3 VP across these two capacitors. And you saw the measurement. 3 VP, I'll show you once again. It is 22.8. Slight variation will be there. That is all fine. Now, actually we should also measure the AC input voltage. That is RMS value of the AC input voltage. These I am measuring at the DC voltage. Please see the knob here. I can put it in 20 if this is the DC voltage. I put it in the 20 range. So once again we can do more accurate measurement if it is in the 20 range. So please note down if there is any correction. 7.7 VP. This is 15.6. This will go out of range because this range is only up to 20. So I'll change the range to 200 and measure VP, 3 VP. VP 24. Okay. Now we have to measure the AC voltage, input voltage also. So I'll put this in the AC range and try to measure what is the AC voltage at our input. So this is the input point. These two wires, I've taken blue and white here as input. So that is this point. Here I'm measuring the input. So it is 5.9. So let us come to the calculation part. Now, I measured the input AC. Remember what I am measuring is input AC over here. And I measured it once again. That is VRMS input. This is the input. VRMS is equal to what I got when I repeated the measurement is 5.7 volt. So input VP is equal to 5.7 into 1.414. That is root 2. 1.414 is root 2 as you know. So the VP value would be 8.059 volt. Okay. This should be the VP. This is regarding the input, and regarding the output that we measured across this capacitor, C1 capacitor, that is, it was 7.7, slightly less than the expected. That will happen. C2, that is the voltage that we measured across these points. If you had noted down, it was 15.3, and that should be double of this. Double of this will come to 16.1. Or you can also take, if this is VP, then see this is almost double of this. Isn't it? So this is 2 VP that we measured. And the voltage across C1 and C3. This is the point where you measure the 3 VP, and that we got it as 22.5. So that is also very much in agreement with the theoretical expectation. So while the input VRMS, which we measured using multimeter by putting it in AC mode, AC voltage mode, was 5.7 volt. From that, we theoretically calculated what should have been the VP voltage by multiplying it with root 2, and it comes to 8.05. Then experimentally we measured VP across C1, 2 VP across C2 and 3 VP across C1 and C3, and this was our measurement. So this is almost in agreement with the expected theory. Remember, VRMS at the input should be measured putting the multimeter in the AC mode. After that, we are using this capacitor diode series combination to multiply that VP voltage. Hence, here we are measuring the DC voltages. Please make sure that your multimeter is in the DC mode when you are measuring VP, 2 VP and 3 VP. Thank you. Hope the circuit is made simple and the voltage multiplier construction is also done. So now we have done the experiment for one input voltage. Now it is possible to change the input voltage and repeat the experiment for various values of input. But one important point that is to be noted to avoid error is that when you change the input voltage, please see to it that you switch off the input supply and then short the capacitors before you change your input. That is, you take a wire and just short the two terminals of the capacitor like this. Of course, not in the diagram, but in the circuit. So if this is a circuit, this was a circuit. So the positive and negative ends of the terminals of the capacitor should be shorted with this two ends of a wire. I've taken a wire. The two ends of the wire should be used to short the capacitor. When you do this, a slight spark may appear. That is due to discharging of the capacitor. So make sure that you switch off the power supply or just take out the input leads that you had given here. These were the input leads that we had given at the input, isn't it? So remove at least one of the leads, then do the shorting. Take a wire. I've taken a small wire. Sorry, I'll take another one. I've taken a wire. Two ends of these wire are male leads. So just touch the two ends of the capacitor, two terminals of the capacitor, like this. If you had noticed, you could have seen a small spark that came here. So make sure that you disconnect this from the input supply and then do the shorting. Why you need to do this is that because the capacitor would already be charged for a VP value. Say if the VP value is, in our case, it was around 8. Now, if you reduce the input voltage to say 3 also, this VP will be stored here and that will create an error in the output. So before changing the input, make sure that you switch off the input and do this discharging of the capacitor and then charge it to the desired value again. Then only you will get the correct output value. So please note this point and repeat this experiment for various input voltages. Thank you.